let's talk about vectors. And the first thing we have is a definition. And it says this: a vector shows direction and magnitude. Okay, so that may not really give you much, well, direction or magnitude, that's a pun, about what it really means. But this will make sense as we go. So I'm going to get some direction based on a coordinate and magnitude based on the length of the vector itself. You'll see what I mean as we go. So we're going to graph each vector. And each vector, for now, is going to start at the origin. So we're going to start it at 0, 0. And it's going to end at the coordinate 4, 2. I know this looks like a coordinate, but based on the funny little pointy brackets here, it's really a vector. So over 4, up 2, and there's your dot. Let me grab a ruler. And there we go. So this is a vector. We connect from the origin to the end of that point. And when we do that, that shows me that I'm moving, well, in this direction. So I'm moving in this direction for that magnitude. It may be miles per hour, who knows what the actual units of measurement is, but it gives me a direction and a magnitude. So these are pretty straightforward. Well, straightforward, get it, because it makes a straight line. So what we're going to do is draw the next one, and it is at -8, +9. -8, +9, we'll connect it to the origin. Again, these are pretty easy to figure out. There we go. And then the next one is -4, -10. So we're going to go -4, -10. There you go. And you just drew your very first 3 vectors. That was easy. And it was fun. Okay. Things get really practical at this point. You're flying a drone with a trajectory based on the vector 3, 5, and that's per minute. However, the wind is blowing with this vector. Now, because of the graph and the fact that things won't fit the way I want it to fit, I'm actually going to change this one. And I should have done this before I printed the notes, and I apologize. 1, -2. We're going to do that right there. Trust me on this. It'll make more sense. So what's happening is I'm flying a drone, and I'm flying it based on this vector. So let's just go ahead and draw that first. And there are 2 questions here. One of them is, where will your drone be at the end of 1 minute? Where will your drone be at the end of 2 minutes? So we're going to use this graph for 1 minute. And we're going to use this graph for 2 minutes. So here goes. My first vector, almost said trajectory, is going to be 3, 5. So we're going to go over 3 and up 5. Here it is, right there. This is my drone. So I'm flying a drone from this point, and it goes in this direction with this magnitude, this many meters per minute, or whatever it may be measured in. I know it is per minute. However, the wind is blowing with a vector of 1, -2. So here's the way my drone is supposed to be flying. However, the wind is blowing it based on a 1, -2 vector, which actually would go here and here. And I would love to draw it from the origin, but now I'm not, because I'm going to connect them. So here's my wind vector. This was my drone vector. But from the end of this one, I'm going to go 1, -2. So from here, I go over 1 and then down 2. And I do that. And I'm going to connect them. There are some online assignments, some Delta Math, where you'll have to take 2 vectors that are sitting at the origin and just drag one of them to where the tail of one of them is sitting on the head of the other one. So the arrow is basically pointing to the end of the other one, and you're going to just follow it along and see where it lands. So here's really what's going on. I'll do it in purple. Final answer is this vector right here. I know that's a lot of arrows and randomness, but I'm flying my drone this way, the wind is blowing this way, and therefore I end up here. And so the answer is there, which would be 1, 2, 3, 4, 3. So 4, 3. That's what really happens. Okay, so that was pretty straightforward. Let me show you another way that we could do it. And I'll do it right over here. Basically, it's like this. If I had 3, 5, and I want to add it to 1, -2, it's going to be this easy, trust me. So there's my drone, there's the wind. 3 plus 1 is 4. 5 minus 2, 3. There you go. That's it. And that gives me the same thing. Now, you're probably thinking, well, couldn't I do that? Isn't that faster? Yes, it is, and we will do that a lot. But I want us to see the graph, too, because it really gives a representation. You fly a drone, the wind blows, it pushes it here. That's really what's going on. Okay, we're going to do this for 2 minutes now. So we're going to go 3, 5 for 1 minute. Here's my first vector. I just flew my drone for 1 minute. And now I'm going to fly my drone for another minute. So we're going to go 3, 5 again. Here it is. 3, 5. And so that is me flying my drone for 2 minutes. Well, the wind is also blowing for 2 minutes. So we're going to go 1, -2 twice. 1, -2. There's your first one. So here's the wind blowing for the first minute. And now from here, we're going to go 1, -2 again. Here's your wind blowing for the second minute. And so my final answer is this right here. Wherever that is, and that is at 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6. So my final answer is 8, 6. Well, let me just kind of make some sense out of this. If this is what happens after 1 minute, this is what happens after 2 minutes. Notice it just got doubled. So double the 4, double the 3. There you go.